Okay, my outstanding friends, we are going to learn a little bit about everything. Now, what are we looking at here? Well, that's light coming through a venturi and actually splitting the non-material part of light. There's no dark particles here from the dark particle part of light. A lot of the white is going with it, but all the dark is going this direction, and only the white is going this direction. These are the kind of details that you have to really see to start thinking. You see, you got to really look at all these very, very fine ripples. You see those? What's causing all that? And why don't you see that on the other side? And why do you see all those little black particles all over the place and none on that side? Why? All right, we're going to get deep into this, and I'm going to show you. I got a ton of shots here. Hold on. All right, all from like down here down. I didn't want to get rid of all that stuff. That's some of my geology stuff and Mudfossil stuff. Down here is all about the light, and I'm going to show you pictures that are just going to freak you out, and I mean freak you out in a lot of ways. Now, let's get started. These experiments were done by Rod Warren. I want him to get credit for this. I didn't do these. I worked with him, and I have the same equipment here. I did some, but I didn't do anything like this. It was very frustrating for me. He just kept doing it for years, and I can never thank him enough, because the first one I saw, I believe, was like this one or something. I said, "Wow, what did this guy do?" And I remember what it was. It was this one right here. It was basically this one, only I could see the light accelerating. Wait a minute, let me show you that. All right, I think it was this one that clinched it for me. I could see the light accelerating. I mean, it's not supposed to do that. I know this is from a red laser, pulsed red laser. And I could see, obviously, acceleration and this explosion of light and these reverse electromotive forces going back that way. And this is basically my background is in this sort of stuff, electronics. And this is visual electronics. I could never visualize. I knew it had to be dipoles, but you can't visualize, you can't prove it unless you can see it. And here it is right here. The black is separated from the white. This is fission, that's fusion. It's absolutely incredible what Rod did. He didn't realize he did it. He just was trying to make a double slit experiment. And he used rounded slits, so it created a venturi, which caused this acceleration. And you can see it. It's just, there's no question about it. And just as it started to accelerate, first of all, you would never see this wave ever if it wasn't for the fact that it's accelerating. And you would never see these. And they're here. They're all over. You see these? And that one, and this one, this one. That was a complete one, just like this. Only you don't see it. The only reason you see it is it goes banging backwards. That's why just the front of it's lit up. You see it? This one's being pulled forward. That's why you see this one. Otherwise, you never. They're here. They're everywhere. All of these, they're everywhere in here and everywhere in here. You just don't see them. The only way you see this one is because it's right dead center going through the venturi, which means it's being sucked right through there like a rocket ship. I mean, look at that. Otherwise, you would never see these. You never, ever see these. They're there, just don't see them. All right, here's another one Rod did. This is exactly at the point of acceleration. The wave has not hit here yet. The only reason these little particles are glowing is there's a big magnetic field around the particle. So now it's starting to really get sucked forward. And it's just now moving forward. All right, that's why it's glowing, because it's trying to push everybody out of the way. Anytime you push something else pushes back. It's a push to shove. And the guy that's pushing's got the major amount of energy, pushes everybody out of the way. They still glow, but not like this. That's glowing because it's being accelerated forward and pushing really hard against everything. And as it pushes harder and harder and harder, it gets stronger and stronger and stronger. That's what they call the flavors. And here it is right here. Oh, hold on. These are the flavors. Back here, there's no energy to speak of. It's starting to get energy, and it gets brighter and brighter and brighter and brighter, and then it explodes. More and more and more and more energy because it's pushing back against its own self. This is pushing back as it bounces, and this is bouncing into it, and you end up with this down here. And the only thing that can go is the white just has no mass. It just can fluff right through there, and the black slaps it through. Okay, I'm sort of going to run through these semi-quickly. This is the light just starting to accelerate. I think I've shown you that. It's pushing all these little particles which are in the air. They have fields of their own. Every particle has a field. If you push against that particle, it pushes back and takes on a little bit of energy. Now, with the CMOS, it's able to pick up these tiny little bits of energy. It's just fabulous. It's hard to believe, but it's true. This is the acceleration of this wave as it gets sucked forward towards the Venturi. A Venturi is a fully understood accelerator of water. And light is nothing more than little tiny particles, basically little drops of water almost. You can think of it in the exact same way. And they are sucked forward through the Venturi, the white being compressible and the black being non-compressible. The white can get down and squirt right through this tiny, tiny little Venturi. And when it does, it goes all by itself as white, separated. I never thought it could happen. But at the subatomic level, it does separate the black from the white. Above the atomic level, they do not separate. They don't separate. They're tight. That's called a strong nuclear force. They just don't come apart until you rip them apart, creating electricity. That's generation. That's a whole different story. Now, coming out from the Venturi this way, looking into the Venturi, you would see this. So this looking here is just like us looking here. So we're looking in to the light as it comes through, just spraying at us. And what is it spraying? Higgs fields. Those are Higgs fields, spraying right out of here. And at first, they're just white. You see, they're just white for a while. And then all of a sudden, the Higgs fields show up here. Boom. Around the edges, they show up. And in the front, they show up. And then they just turn back into light. It started this way too. You see this? This is coming out of the Venturi at us. It started with the same form. Only this is a little spinnier because you can see the actual particles at this point. It's taken on a little more energy. But back here, you see basically the same thing. They're coming in, and they come back out almost the same way. Now, this is blue, spinning like crazy, and drifting to the left and slowing down. Blue's very fast. We'll go over that in a minute. This is the photons. We'll go over that in a minute. This is the particle that is an anti-particle, semi-particle. This one here's got me. Well, I figured it out eventually, and we'll go over this. But this is a reverse particle colliding with a normal particle, Higgs field. It's a reverse spinning Higgs field going this way, colliding with one going that way. And that took me a long time to figure that one out. So now we've seen that. Look at this. I'm telling you, Rod did some stuff. I don't know how he did this. I have no idea. And he wasn't a big communicator, but boy, I'll tell you, he sent me stuff to freak me out. I don't know what to think about that. I don't know how he did it, but I'm sure this is the pinch point. how this was done with a series of nails, or I don't know. He had techniques. I have no idea how he did some of the things, but I was just stunned at the results. You've seen that, you've seen that. This is Higgs fields on steroids. That's the white coming down. And every little white particle ends up creating a little circular field with an inner magnetic field. You see the little white spritz coming out of here? This is the best one I could show. And it's black, white, black, white, black, white. And now it's all of a sudden turned into a field. You see the white doesn't keep going? It starts to create its own field. And somehow it's creating an inside reaction, like a reverse reaction. Usually you see it getting wider and wider and wider as it goes out, yes. Well, this is starting out here and getting narrower and narrower and narrower as it goes in. I can't explain it. Very strange. But those are the Higgs fields. They know this. They see those. And CERN has their own little doodle about Higgs fields. I hear this is it. These are supposed to be the Higgs fields they see. These little circular things. They're smashing huge things together like this. So they get all this debris. And eventually, every now and then, you see one of the things that we started with, which is the light. They're seeing light. And they're seeing every different frequency. And then they're seeing it spinning in circles. Same thing we see. Only, and the blue ones take off, never come back, because they're the tightest held. The red are way on the outside, and they sort of bounce around, and sometimes they stick around, they come back. But the white, white is just a real strong energy. Blue is just a little bit below the white, and these go and they never come back, because they're the tight ones, very tight. Here's the blue spinning through. Now, it comes in real fast out of the Venturi, and you can't even tell there's two particles there. Every dot here is the back-to-back dipoles. Here you can finally see them as they slow down. It's spinning to the right, which means it would drift to the left, and that's exactly what it's doing. And it's going from almost touching each particle to sort of opening up a little bit, which is what happens as they drift to back down to the blue frequency or below. Light slows down. I can't believe they think it doesn't slow down. It's just impossible to think that. They say in a vacuum. Well, first of all, there is no vacuum in space. There's none whatsoever. So all of these space telescopes to say we're 500 billion light years away from this or that, no. They have no idea where we are. Everything's slowing down. They could be very, very close to these things, and coming through a very dense fog, slowing down very quickly. This is what's in our local neighborhood. This was taken with a cell phone a couple of years ago. A guy got a new cell phone. He took this picture somehow with some kind of app. I don't know what it was. And I could never contact him again. Now, he sent me this one and another one, but this shows all the fields. And you see how they and that's how push to shove works. And that's because of the spinning planets and so forth. This field is not created by this. This is our moon. The moon has no field to speak of. You see this field? It's overlaid on the moon. I don't know what to think about this, because it's behind the moon. I would say it's back in somewhere in here, some planet spinning and creating this field, but the field is overlaid on the moon. Like I would have expected to block it out like here, but how did it get up on top of the moon? I don't know. And what is this? Yikes. And what is this? Double yikes. And all of this field effect stuff. There's no way in the world light is going to go through that and not slow down. It's just impossible. Ridiculous to think that. It's not possible. And there is a ton of dust. You look out and there's cosmic microwave radiation everywhere. It's the particles of light that just slowed down to where they're sort of drifting around, blinking on and off. This shows how light spins. It spins in a circle. It doesn't flap like this. This is what light does. It's a magnetic particle, a photon. It has a magnetic field surrounding that photon. It's like a bubble, like a balloon. And it spins just like this. Some are going to go over this way, some are going to come under this way. You see, it's just like a drill bit spinning. It's exactly what it's doing. Some come way over here, some come way over here. I showed you, they're all over the place. You just don't see them. The only time you see them is when they get accelerated and get energetic. So most of it's going through the center, but some goes out, and they hate each other, so they stay. You stay in your lane, I'll stay in mine. You see how unbelievably perfect that is? They don't want to be next to each other. They set up these, they call it interference. They think they're flapping like this and that. No, they're saying, you stay away, you stay away, you stay away, you stay away. And that's how the rays come out of here in this arrangement. It's because it's spinning. Here's another one from Rod. No clue how he did this. Obviously something is pinching the particles, and it looks to me like each one of these is basically a photon, and they're being crushed together and into this and then spreading out. So something is holding them here. How he did this, no clue. But I can tell when you see increased energy, it's increased whiteness, brighter and brighter. And it's spinning. All light spins. And it's coming out of here, spinning, 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 spinning. Look at that. Isn't that something? This looks like the back of another pulse. This is from a pulsed red laser. Poof, 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 poof. And this is one pulse, and I think that's an exiting pulse. We're looking at the back of it, just like we're looking almost at the back of this one. I believe that's what it is. And again, I really have not been communicating with Rod, but it's just fabulous, the work he does. It's just amazing. And you see these here? Look at every one of those little tiny little spots coming out of it. Just is incredible. Absolutely mesmerizing to me. You see this? This is light gaining energy. It's coming in, spinning, and everything's fine. And then all of a sudden it says, whoa, what's going on? There's a roadblock up ahead. And it starts to crush into each other. And see how it's wired here? All of a sudden it starts, hey, get out of my way, get out of my way, you get out of my way. And then it starts pushing against each other, and they form just a really solid block of energy. And it just keeps increasing energy, going through from red to yellow up to white. And white is pretty raw energy. Now, where the black went, I don't know, because I don't see it yet here. And it might be, at this point, just beginning to separate, I don't know. But you can see it's gaining energy as it's crushing itself against its own repulsiveness. And then the result is it squirts out the white. This one here is the crazy one. This one, it came through, we're looking right into the Venturi. That little particle went to the left and all the rest went to the right. That one there, I believe, is gathering energy into itself rather than spitting it out. That's just a guess. All I can tell you is that normally they come out of here and they start to come over here and reconfigure themselves into Higgs fields. Which the Higgs fields are when they join back together, just like it was light. It looks basically just like it started before. I think I've shown you that. But this one, no. That's a different story. Let me come up close to that so you can see what's happened there. You see that little trail behind it? And it's glowing like crazy. Totally different than the rest. And the other thing about this one is these have compressed differently. That one's extended and turned blue, which is an increase in energy. All right, I think I've shown you this, but anyway, this is the red the red photons increasing in energy. Back here, they would call that one of the flavors of neutrinos. It's not really a photon yet. Side, like this way, is like an Oreo cookie looking thing. black on white and then black on the bottom. Now it sort of tips sideways and you go to this kind. But straight into the Venturi, you actually get a photon because the photon is crushing against itself. That's the only reason you can see these photons out here. You normally wouldn't see that. The only reason you see that is because it's bouncing off its own self, and it feels like it hit a wall right here. And it's turned into a photon, which would bounce back at you at some frequency of color, depending upon what it bounced into. Right now, it's bouncing into itself. So it's just sitting there in the middle of nowhere land as a photon. I think that's not normal. All right, you saw the red photons. These are the green, which are just exactly the same. The characteristics of them are the same. Now, these are showing up as photons. I believe they're coming in to the Venturi this way. But I'm not certain, to be perfectly honest with you. They may just be slowing down after coming through this way. I don't know. But at any rate, you can see quite easily they are identical in structure. Now, this one here is getting ready to flip. As they come through the atmosphere, they charge up. And this one's getting charged up, the leading one. And it's going to flip to the back, and then the trailing one will come to the front. It's called a muon wobble. And I believe, I'm not sure of this one way or the other, to be perfectly honest with you. I can see the identical same, I guess they'd call them the neutrinos, the flavors. You see the black, white, black. Well, we had the same thing basically with the red. And then it turned into photons. And I believe it's because it's coming this way. I don't know. It could be going that way. It doesn't matter. It's the same particle. I guess it does matter, but it's still the same particle. Okay, this one here, I'm pretty sure what I'm seeing, but I'm not 100% positive just about anything anymore. I think this is the photon coming through. It's gaining energy, and then it gets kind of bright, and the next thing is it hits the Venturi, and it squirts out all these little rays of energy, of light. You see them? So here it is right there. There's the blob. Gains energy. Boom, 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 getting hot. Bam! And just squirts out all the white through this side. That's what I'm seeing. And here you go again. I think I showed this, but you can't get enough of it as far as I'm concerned. These are the black particles, and you don't have the wave-ish looking stuff going this way. You have just an array of basically debris and blackish stuff in the middle of it. And here you just have very nice, consistent, perfect waves with no black whatsoever. None, zero. I can't find any. None, zero. But magnificent, gorgeous looking, perfect, very, very, very close waves. Almost touching each other. And on this side, there's no waves. That I can't really understand. There's a lot of stuff I don't understand. That's why you got to look at it 100 times, 1,000 times sometimes. I've been working on these things for 10 years. And I find something new frequently, not a lot anymore, but boy, I'll tell you. But look at all this dark stuff. That's actually dark matter. That's the only thing that has weight. This has no weight. This is what you put in your car. It's energy. That's where the matter is going this way. The black stuff is the matter, and light is made of matter. 1,839 or so of these little dipoles turn into one proton. All right, so that's my calculation. 1839 turn into one proton. All right, I did show you this particle, which was, I believe, a reverse spinner. Now, and I can't be positive of that, and I can't be positive that it is this particle either. But I believe it is this particle right here. Again, Rod just sent me a lot of stuff with very, very little communication, and I believe that's a reverse spinner, and when it hit this field here, it tore the particle off, and what's going to happen to it now, I have no idea. But I don't think they can get any smaller than this particle, and I think it's been ripped from this field, and then the field just collapsed. It's just gone, because the particle no longer is attached to the field. Some of this stuff is just stunning stuff. It's just amazing. And the other things that Rod found, which I didn't push because they were like people inside the light and stuff like that. It was, you know, it's crazy stuff. And I don't know if it has anything to do with reality, but I'm going to show you what he sent. And I didn't push that, and I think maybe that probably annoyed him because he was doing all this work, and I think he wanted to find life within the light, because it says in the ancient texts, we come from the light. If they ask you where you came from, tell them we came from the light. That was from Jesus Christ. You want to argue with him? You argue with him. This is the light coming in. Anytime you get bunches of it together, they get glowy. When they're separated out like this, they take on less of a push. Anytime they're pushing each other's areas, they start to glow. That's what energy is crushing field. All right, get ready for this, because after this I'm going to show you some that have faces in the light that I can't explain. These are the particles spinning through, and they're hitting each other here, so we're getting some pretty good glow here, a little glow there, a little glow. But where there's no real interaction, you just don't, they don't get glowy. Just put it that way. Pushing and shoving always creates energy and glow. Now, I was going to show you, let me show you what Rod was doing with this. Look at this. Look at that. Look at that. It sure has the look. Look. It sure has the look. Now, I'm going to show you some other ones. What do we got here? Look at this. If you take a look at this long enough, it almost looks like it could be a Jesus Christ type of figure. And when you see this glowy stuff, it means it's like more impact. It's like raised up here. You know, that's the type of thing. It almost looks like his cheek. And of course, the eyes and the hair and all that, the nose and lips and all that. And this looks like the devil spitting something out at him. There's the horns of the devil going off this way and that way, and his nasty looking mouth spitting something nasty out. And Jesus is saying, you're a bad guy. I'm not going to get upset. You're a bad guy. I don't know. And these were he was sending me a lot of things like this. And I couldn't dismiss them, but I couldn't promote them either. Just promoting my own stuff was making me have people get real upset at me. But I can't dismiss this, and I don't know what else to say. Huh. And I can never be, you know, thankful enough to Rod for working with me for years, literally for years. And as far as I'm concerned, he's number one as far as light research goes. Now, he wasn't into the atomic part of it, but as far as being somebody that did experiments, you just can't get any better. Just never going to happen. You know, I'd ask him, try this, do this, can you just take a look at that? And, you know, he'd just send me pictures of what he did after I make comments. And Dylan was the one, his nephew, that sent me this kind of stuff. And they've sort of both gone a little dark, which is, you know, I understand that. People don't want to be involved in this stuff forever. And I'm caught up in it, and I've been involved in it forever. I'll keep doing it until I stop breathing oxygen, is all I can tell you. This stuff is amazing, first of all, and it's stimulating as hell to my mind. Look at that dipole. And everything's a dipole. Everything is. This has two magnetic fields. I think I know why. There's a magnetic field here. They're going straight up. Why would it have two fields? That's not natural. Well, I mean, it is natural, but it's not normal. They normally have one field. Anyway, that's, let me think of if there's anything else I want to show you here, which I don't think there is, but let's hold off 1 second. Yeah, I just want to show you this real quick. You know that these are the same particles they found at Fermilab back in 2013 or so, and so did we. And these are the same particles. We started with light. They started with the huge particles like this, but they could find these. They just didn't know where they came from. And it did not work out well when I tried to discuss it with them. Now, you saw the red and you saw the green. They're both the same particle. You see the green here? They're coming through the same venturi at the same time, and the green is so powerful, it just pushes the red right out of the way and makes it tumble. Normally they don't tumble like that. They normally spin like this according to the upspin and downspin of the Earth. This time they're spinning in a barrel roll. That is just not normal. It doesn't happen. The only time you ever see this is when one is pushing the other one out of the way, just like this. I don't think you're ever going to see that again. I've never seen it before. And that was from a guy named Fabian. I think it was Fabian Brule. And I can't get a hold of him either. I can't get a hold of any of these guys again. And it shows that the green is very strong, pushes the red right out of the way, and reconcusses way out here. So it proves a couple things at once. And that barrel roll, as you're seeing right there, you don't see that. That does not happen. That does not happen. They do not barrel roll. But when you get that green coming through with all of its energy, pushing against what would be spinning like this, it starts to flop it that way. Get out of the way. And then that's what you're seeing right there. Very, very interesting to see that. There is normally upspin and downspin. That's just not normal. You see this? In physics, upspin and downspin refer to the two possible orientations of the intrinsic angular moment, which is the spin of a fundamental particle like an electron, represented as either plus 1/2 or minus 1/2 along a specific axis, often the z-axis. Well, let's take a look at this. All right, I just showed you an electron spinning that way, not spinning this way, which I agree that they always do. But when one pushes the other one out of the way, you can barrel roll them. First time I think it's ever been seen. Well, I know it's the first time ever. Now, they're showing electrons spinning this direction and then electrons spinning this direction. So they're saying this is the one axis, upspin or downspin, whatever they want to call it, and this is the other one. All right? That's not the case. They're spinning this way, always. It's just that they present the white up here at the top and the white at the bottom in this one, and in this one the white is here at the top and the white is at the bottom. That's what upspin and downspin is. Let me show you one more time so we don't get confused, upspin and downspin. We see here, we can create barrel rolls. They're supposed to go like this. And they do go like that unless they get pushed, as I just showed you. All right, you see this? That's the particle coming through. It's straight up and down according to the Earth, North and South Pole according to the Earth. But it's flipping like this. It's still going like this, even though it's going in that direction. You would think it would corkscrew like this, but it's not. It's spinning like this because of the polarity of the Earth. So this is downspin. That's downspin. to me, the glowy part being down is downspin. If the glowy part was up, it would be upspin. And I show you the red flips very quickly. Here's the red. This is upspin, the white is up at the top, and the next, it's the same particle, I believe. I don't think we're two different particles. This particle here now has gained a little more energy and flipped. So the bottom white part now is in the front. And the top white part is back here and will discharge. They get glowier and glowier as they come forward. That one's charged up a little bit. You can't see it in this picture, but when I show you the very extreme details, you can see it quite easily. Right here, you see it? That's the glowy one coming forward. And these little white particles are the reason it's glowing. It's pushing through those particles desperately to get to the other side, to just keep going. So it glows. This one doesn't because it's shielded by the black. When that fills up, and this one comes around front, and it's just, they spin like that. Straight up and down though. They don't flop around like this until you do what we did with the double slit, or Fabian did. And again, I can't get a hold of him either, but that's the only time you're going to see a barrel roll like that I could imagine.